Thanks for coming. Appreciate everyone showing up here for this session. This is the second chapter of the desktop virtualization best practices. We gave, actually myself and Pierre Marmignon, who is not here this time, unfortunately had a death in the family and had to cancel last minute. But I've asked Denis to join me. So Denis, if you could introduce yourself.
Hello, my name is Denis Gundarev. I'm glad that Shawn invited me to do this session, and I hope that you will like it.
Great. So this second chapter of the desktop virtualization best practices, we're going to be focusing a lot on operating system streaming. And in the Citrix world, that of course involves provisioning services. So we'll spend a bulk of the time talking about that. If anyone is active on Twitter, both Denis and myself are quite active on Twitter, so please feel free to tweet about the session. The BriForum 2013 hashtag can be used, and then just post whatever comments you like about the session on there. So really quickly, quick introduction about myself. I am a consultant based in the Chicago area, so most of my consulting is done in the Chicago region. I do some occasional consulting outside of Chicago, but most of my customers are in the Chicago region. I do speaking at events like BriForum, TechEd, Tech, VMworld, those type of events, Citrix Synergy. I also do an independent training on terminal services and XenApp and XenDesktop with Dr. Benny Trich. The curriculum was originally created by Brian Madden back in the early 2000s. And then after Brian got acquired by TechTarget and his site went over to the TechTarget team, Brian stopped doing the technical training class, and myself and Benny Trich continue doing it. So we do that about 4 or 5 times a year, and there's information on my website about that. And then the last thing is I've been doing for the last 2 years now a desktop virtualization roadshow with TechTarget, where I go to different cities and explain to people kind of like my perspective on what's happened with desktop virtualization over the last 5 years and kind of where we're headed. Not so much do we focus on the consumerization piece and that kind of stuff, although we touched briefly on enterprise mobility management. So Denis?
My name is Denis. I'm from Russia. I'm a little bit crazy, and I'm working with Citrix products for quite a long. I was a customer, a big customer for Citrix. I was a Citrix employee. Now I'm a Citrix consultant based in Bay Area, in San Francisco Bay Area. And I'm doing trainings, I'm doing consulting, and another one thing that I'm doing, I'm trying to organize Bay Area Citrix user group. If you are from Bay Area, please join the meetup. We have monthly meetings with good content.
Great. So really quickly, I want to run through the agenda of what we're going to be covering. We're going to spend a little bit of time talking about a recap of Chapter 1 of what we covered last year, what Pierre and I covered last year. Is anyone in our session last year? Desktop Virtualization's Chapter 1? Okay, so a couple of you guys. So we will cover a very, very high-level overview of what some of the conclusions were from that first chapter, just to refresh people's minds or give you an update. We'll cover a little bit about kind of a high level of what PVS does. And we're not going to talk about it, academically what it does. We're going to talk about in practice what it effectively does from a network perspective and from an optimization perspective. Then we're going to spend some time talking about PVS image types and how you prepare your gold image that you leverage for PVS. Talk about write cache types, some PVS optimizations you need to be aware of, and cover how you can do high availability in a PVS environment. And then finally, we'll cover a bit of a wrap-up at the end. So, Chapter 1 review. Denis and I are just going to kind of trade off and talk about these topics and kind of what our perspective is on how you should be thinking of these things. When you're doing XenApp and XenDesktop sizing of your environments, of course, it's always best to do this sort of methodically, do measurements, do baselining, try to gather statistical data from your prior environment if you had physical PCs or physical servers you were using in the past. When you start porting that to a virtualization environment, you don't want to start over from square one kind of guessing at these numbers. So having statistical data is really good. But when it comes to overcommitment, which is a very common topic, of course, for server virtualization, the most important thing that I always try to do when sizing environments is do not overcommit your virtual CPU count or your RAM count. RAM is definitely a no-brainer from my perspective. If you're building out virtual servers and you have 128 gigabytes of RAM on your hypervisor host, slice up your 128 gigabytes of RAM for the number of VMs you want to serve, and that's how much RAM you allocate. Don't do a lot of overcommitment, because overcommitment means you're going to be swapping on your hypervisor host, which means you go to storage when you swap, which means things get slow. So generally speaking, always try to avoid over-allocating RAM. On the virtual CPU side, if you can afford to not overcommit, it's best to not overcommit. Now, unfortunately, the problem that you run into is sometimes people can't afford to buy enough hypervisor host hardware to support the number of VMs they need to run. So as far as overcommitment ratios on vCPU, what I typically tell customers is try to not get too aggressive in this front. Doing a 2-to-1 or a 3-to-1 overcommit of vCPUs to hypervisor cores is an okay thing. But all these numbers that were quoted over the last 5 or 10 years where people say 8-to-1, 10-to-1 overcommit ratio, that's kind of crazy. If you get that aggressive on your overcommit, your hypervisor is going to have problems scheduling resources, and you're going to have a resultant poor user experience. So typically 2-to-1 or 3-to-1 is where I typically max out.
Yeah, and you can always test how it works. You can put yourself on the user place. Just take a laptop that is like 5 years old and remove all memory that you can remove from this laptop and check how it works. That's how your users feel when you overcommit in CPU and RAM. Yep. So you need to size your VMs. You need to know what exactly applications will users use in your VMs. And there's no golden rule, because some customers using desktop virtualization for developers, and they need a lot of RAM, they need a lot of CPU. Some customers are using it for call center, and basically there is just one application that doesn't consume a lot of memory or CPU resources. You need to right-size your VM all the time when you're doing your virtualization.
The thing you want to make very, very careful if you're not doing here is don't make the assumption that just because somebody had 4 gig or 8 gig on a physical PC that when you port them to VDI they necessarily need the same thing. Because if you look at the data that's gathered from your systems management agents that you collect up information on all your PCs, you may find that a person with 4 or 8 gig of RAM on their PC is only consuming 1 or 2 gigabytes of RAM. So there's no reason to give them 8 gig on your VDI stack, because you're going to be wasting that 5 or 6 gig of RAM, which ultimately is going to reduce your scalability. So there's several vendors here that, of course, have data collection tools like Lakeside Software, Splunk, that kind of stuff. Leverage those tools, gather the right metrics, and then size your VMs accordingly.
Or at least use Windows Performance Manager.
Yeah.
To
Perfmon, very easy way to gather that data. IOPS, we're going to talk about IOPS in more detail in terms of how PVS changes the IOP picture. But IOPS, of course, I/O operations per second, very, very important if you're doing a VDI design. And the most important thing about IOPS in my mind is not focusing on the IOPS average, which is interesting because almost everywhere you read about sizing VDI environments or sizing terminal server environments, all they talk about is IOPS average. And the most damaging thing about IOPS average is it's something that's not a good way of sizing the environment, because you're making an assumption about the patterns of activity being somewhat flat, when in reality, when a machine operates and it needs data from the disk, it's very, very bursty in nature. So you power the machine on, you might have an IOPS spike in the hundreds of IOs per second or even thousands of IOs per second. And if you're averaging your IOs as a way of scaling your workload, you're going to have problems, obviously, with boot storms, but you also have problems with logon storms, people launching applications at the same time. Everyone's heard the old term that you need between 8 to 15 IOPS for Windows 7. Has everyone heard that general term? And the problem with that, and the easiest way to disprove that, is think about this. A typical IDE SATA drive can serve somewhere in the neighborhood of 80 to 120 IOPS on average. If all you needed was 8 to 15 IOPS on average, then why would people ever buy SSD drives for laptops or desktops? It makes no sense. If the IDE SATA drive can serve 60 to 80 or 60 to 120, why would I need more than an IDE SATA drive? The fact of the matter is Windows can and will use hundreds to thousands of IOs per second. What ends up happening is if you end up slowing that down or gating it because you don't have enough storage performance, you end up with disk queuing happening. When you disk queue, the user experience on the desktop becomes very poor performing. So make sure you scale for peaks.
You need to think about how you manage your settings on your VMs, how you deploy these settings. You can use group policies, you can use group policy preferences, you can use scripts or any other user environment management tools, but you always need to plan this, because it's really important during the logon time when users are logging in. It's affecting them, and if they will wait for their desktop for 5 minutes, it's not acceptable.
Yeah. And I always say too, there's always a big debate of do you need a UEM tool or not. Of course, it's environment dependent, the complexity of the environment, how many different sites you have, different kinds of user configurations. But if you haven't done much work yet with group policy preferences, you really should dig deep into that, because my feeling is that probably 80% of customers could get by with GPO and GPP. It's actually a very, very flexible, powerful framework, and if you get very deep into that, you can do a lot of stuff with it. ADM as a method of delivering settings is, of course, a legacy format. The ADM has been superseded by ADMX, but in both cases, a majority of the things you needed to do in ADM or ADMX can be done in GPP. So definitely dig deeper into that if you haven't already.
And what is great with GPP and GPO, that everything is documented. All settings are in one place, or at least you can find them. Comparing to changing the registry on the machine or using some custom scripts, you have everything in one place, and if you will hire another one system administrator, he will be able to find this information and know what is actually in your environment.
I've worked with a lot of customers in the past where they would bake some of that stuff into the base image, and of course when they rebuild the base image or someone else comes in, they don't understand where these polluted settings came from. So oftentimes anything you need to define as a registry entry or copy down some files or something like that, always put that into GPP because it's self-documenting. You know why the stuff is there. Also, if you're an SA customer of Microsoft and you have MDOP, you can use AGPM to help you document what the changes are. There's a question back here. Right. Excellent point. And I think one of the most powerful things in GPP that I absolutely love is item level targeting. And if you haven't done much with item level targeting, it is incredibly powerful. You can do different settings based upon machines' OU locations, based on user OU locations, based on whether something is a laptop, if it has a battery, if it doesn't have a battery. There's so many different complex rules you can construct about how settings get applied. It's very, very powerful.
Bitness of operating system, what operating system you use, everything can be targeted using.
Yeah, it's incredibly powerful. This one, understand folder redirection and RDSH home. I'm actually looking forward to two of the CCS guys are going to be giving a session about folder redirection because I have been a very big proponent about not using folder redirection for certain circumstances. And let me explain a little bit why folder redirection can make things very bad for you. Folder redirection, of course, is what a majority of us have been doing over the last 10 or 15 years in order to deliver my documents and other things like that to the users. And of course, it is a default part of Windows and enterprise domain environments that we've all been using over the years. The issue with folder redirection that can cause problems is folder redirection creates a UI deadlocking situation in certain scenarios. So my documents is not typically as impactful as, let's say, application data. So if you do app data folder redirection and you have any kind of I/O delays going back to your file server, it could be IOPS exhaustion on the backend SAN, it could be memory contention on the hypervisor host, it could be processor scheduling issues on the hypervisor host. Any of those things that present any kind of performance problem with the file server is going to end up creating a condition where your UI becomes deadlocked for your desktop user, whether a XenApp user or a Xen desktop user. And the thing that I don't like about folder redirection is I always tell people that this is the greatest sapper of performance that you will never notice. And the reason why I say that is most admins, when you say, I'm having a performance problem in my XenApp server or my Xen desktop session, the first thing they do is jump into perfmon, and they look at the CPU, they look at the memory, they look at the disk, and they're like, no, everything looks fine. I don't see anything wrong at all. I don't know why your performance is bad. The reality is you're not going to see it in perfmon. You're only going to see it in something like Wireshark or Process Monitor, because what's actually happening is the file system redirector is making queries to the remote file server to retrieve files that are necessary for that application. And those kind of delays that are caused by file server performance issues are not going to show in perfmon. You're not going to see them. Yet the user experiences delays in the application. I'll probably do a session next year, I'm guessing, that will show this in greater detail, but since you guys are at BriForum now, we did the session last year, that video is now online for free for public use. You can see the examples that we did for that. And also RDSH home is a very, very important one for XenApp environments. If you're a global environment where your users and your XenApp servers are not in the same geography, so let's say you have users in London and you have Citrix environments in Chicago as an example, when the London users sign on to the XenApp server, whatever their home drive mapping is, by default, is going to become their RDSH home drive as well. That's going to be an automatic mapping. If you don't go in and override the terminal server home drive and make it localized to the environment, every single time they run an application, terminal services is going to go back and look at that home drive location to try to load DLLs and EXEs and all that kind of stuff from that remote location. Now, each one of those file requests are going to take a fraction of a second to fail before it goes to the other locations on Windows and finds them. However, you add up a couple hundred of those in a couple of minute period, and next thing you know, you have 30 seconds of delay. Now, there is circumstances that this isn't used, and it has to do with whether or not the application was compiled with a thing called a TS-aware bit flag, and that's a little bit too deep for us to get into right now, but we did cover it quite a bit in last year's session, so please watch that video for more details.
Yes, but what you will find with folder redirection in most cases, if you will redirect update a folder, you will find that many applications will have big problems with it, including applications that are using Java or applications that are using Adobe Air. You can find a lot of issues with it. It will be slow or it will not work at all. So be careful with update redirection.
And it's not to say that you can't engineer ways around that. Of course, you can always alter where Java stores its cache files, and you can set that to be a local location and that kind of stuff. But out of the box, these tools don't work that way. So you need to go into Process Monitor, figure out what's going to your remote redirected location, and then engineer ways around that. I think the concern that I have around these default folder redirections is most people don't investigate these issues until they actually are told there's a problem. So they don't realize that this is actually happening.
Some people think that when they install XenApp or Zen Desktop on their Windows box, it magically transforms into something quick, fast, and that performing very well. Because many people think that Citrix is doing some improvements. It's doing improvements, but it's not optimizing your Windows. You need to take care about optimization all the time when you're installing XenApp or Zen Desktop.
Be very careful with any optimization packs you find on the internet. Somebody that's prepared a registry entry or group policy file that has all these optimizations, and they say, oh, just import this and turn this on and everything will be great. It's very, very important that you, number one, don't always trust those things, because you can often find they can break your applications. Classic example of this is for many, many years, they had an optimization in some of these packs that you can download that would turn off 8.3 namespace creation. What people didn't tell you is that that could actually break a lot of applications that were dependent on 16-bit based, because they rely on 8.3 namespace for identifying temporary directories and that kind of stuff. So make sure you're testing.
Another one example is disabling Microsoft Windows Update service. You most probably, with PVS, you don't want to have updates installed on your golden image automatically. But if you will disable it, and then during the maintenance next time, you will try to install new application that using Windows installer, you will find that it's not able to install. There are some problems. You can spend a lot of time troubleshooting just because you disabled Windows Update service, which is required for Windows installer. You need to know what you're doing exactly with every optimization. When you disabling Windows Search or when you disabling other services, this can impact some applications that can be bad for your customers, for your users. So you always need to know what you're actually doing by these registry keys that you found somewhere on the internet.
So the important thing is make sure you baseline benchmark your environment. You can do this with EdgeSite for load testing. You can do it with Login VSI. Whatever tool you're going to use, make sure you've done some scalability baselines. You understand what user count you're expecting to see. Then you make your optimizations, and then you, of course, check after the fact. If you have an existing deployed production environment, maybe you can take a test server that, or a server that you use for introducing new application updates, make your optimizations there, have your production users on it, make sure that you let them know that you're doing some testing of some settings, and to let you know if there's any application crashes or any performance issues, whatever.
And if you have a baseline, you can compare performance with these optimizations, without optimizations, and maybe disabling 8.3 names creations doesn't worth it.
Yeah. So really quickly, why did we do a chapter 2 on this? Pierre and I have found that lots of customers had implemented PVS for their XenApp environments, some for their Zen Desktop environments. PVS out of the box is not really tuned for performance and stability. There are some modifications you can make that make it work better out of the box. There's also many architectural decisions that if you choose them incorrectly, you can either end up with an environment that performs poorly or an environment that potentially has a lot of risk because you can experience failures and that kind of stuff. And then the last thing is we want to also cover near the end of this sort of some mythical best practices, things that were accepted as truths over the years, but these days are not necessarily true. So what is PVS?
What is PVS? PVS is basically a solution that can cache your read IOPS. You can place your master image somewhere on the shared location or even cache it in the memory, and it will optimize your read IOPS when you doing this implementation. It's a disposable write filter. Comparing to other solutions that are available on the market that installed as a file filter inside the operating system. This solution, PVS, works on the block level. It works lower than file filters, and it will help you if you have some applications that interacting with file system and they may have a conflict with write filters that are available with other products. So it's seamless for applications, seamless for operating system. It's not image management solution in my mind. It's like inventory and versioning control for your images. You can't manage images using PVS, but you can have a version history. You can have rollbacks. You can have checkpoints between deployment of new application, new version of application, and you can roll back after some unsuccessful updates.
So what is PVS not? And I think the most important one is it's not a write IO caching solution. And why this is of critical importance is when we talk about XenApp and XenDesktop from a storage perspective, they're actually not that different. At the end of the day, it's a Windows Client OS or it's a Windows Server OS. But Windows in general, if you look at the IO patterns between read and write, they behave very similar. So when I log into a virtual desktop or I log into a XenApp session, when the machine first boots up, I'm going to have about 90% read IO. Because I'm 90% read IO bound, this is a place where PVS has an outstanding benefit because all of that read IO that would have otherwise come from my SAN is now going to be served by the PVS RAM cache, which alleviates all of that storage backend performance. Once the machine is actually successfully booted, my IO patterns shift from 90% read, 10% write to about 10% read, 90% write. So in the steady state operation of Windows, be it VDI or terminal server, 80 to 90% of the I.O. that goes back to the SAN is going to be write I.O. Now, why that's particularly important for PVS architecture is that PVS does not do anything for caching writes like it does for reads. Now, that's not to say that PVS doesn't have some things in there that can make this better, because what PVS has the ability to do is to store the write cache that we talked about, the disposable write filter cache data can be stored in different places from where the core image is being delivered from. So if you want to, you can have that write cache be stored on the local hypervisor host storage that's in your server blades or your pizza box servers. The problem that I see with this is if you look at a majority of how customers have deployed PVS, most of them are actually putting the write cache back on a SAN volume. So they're doing cache on device target, but the device target they're caching to is actually a SAN volume that's attached to their hypervisor host. The problem that I have with this is you're really not offering any benefit whatsoever from a write I.O. perspective when you've implemented PVS that way. Because now all the write I.O. is still going back to the SAN. So when we talked about that 90% write I.O. during steady state operation, all of that's going to hit your backend SAN. So this is not an ideal deployment scenario. If you're going to do PVS and you really want to fix some of the I.O. problems, you need to have your write cache stored on the local disks that are hosting your XenApp or VDI desktops. The big problem there, of course, it becomes a trade-off. How many local VMs that support the write cache can you fit on the storage that comes with your hypervisor pizza boxes or blades? Most people, when they order their servers, they don't buy them with high-end amounts of storage. They buy them with the least possible drive sizes because that's all they think they need. But when you're going to implement PVS, you really need to make sure you've got enough adequate capacity locally to store the right cache for all the VMs that you're going to run. So PVS is also, in my mind, and this is again my opinion, you guys may disagree with this, everyone can have their own opinion on this, but I don't believe that PVS is very suitable for high application diversity. Again, the design ideas behind PVS is that I have one image that I'm sharing across multiple target devices. And when I have one image like that, I can't easily handle different levels of image diversity. I can't have Visio on one server and have Project on another server and have Acrobat on a third server. I can do this with multiple different images, but now I've created a problem that I was using PVS to make it easier to manage my image, and now I'm having a situation where I'm managing multiple different images. And it depends on the customer and how much application diversity they need, but I've seen customers everywhere from having 2 to 5 PVS images to having 30 or 50 different PVS images that they maintain. The key thing to keep in mind about PVS image management, unlike managing images and application updates through Config Manager, you can't as easily push out a change to a PVS golden image without booting it up in private mode, making your change, going back to the management console and converting it. So there's a lot of management work that's required to make an update to a gold image on a PVS system. This is not as simple as having classic managed images on a persistent model. The ideal situation is if you have a scenario that supports the model of only having one image and you're doing something like application virtualization where you can solve some of those things through AppVirt, then it's not as big of a problem. But basically what you end up trading off is the caching benefits of PVS for read IO and the image rollback and roll forward changes versus having to manage multiple distinct images. So it all depends on how efficient you are at image updating, how big your team is of supporting the environment. But I would say if you reach a point where you're managing 30 to 50 images, you're probably doing a lot of the same efforts multiple times across those images, and you might be better served on a model that doesn't require 30 or 50 different images. So, and keep in mind, there are ways of solving the things that PVS does without using PVS. There are multiple storage technologies that can solve both the read and the write IO problem that doesn't involve implementing PVS. But that's a whole different topic. But there are ways of solving some of the things PVS does without actually using PVS. But if you choose to use PVS, image management will become one of your problems if you have too much diversity. You can do persistent images on PVS, but it sort of negates the whole purpose of doing PVS, because then the read caching on a persistent image model is not as effective because you have differing data blocks across them. So you start to lose some of the benefits of the read caching. So, but yes, you can do persistent images. From my perspective, if you're going to do fully persistent images, don't bother with PVS because it adds a lot of complexity for not a lot of value. Only use PVS when you're going to have a lot of shared images across multiple target devices. That's where the real value comes in. Most importantly, PVS is not a reason to abandon well-managed desktop practices. So one of the things I think a lot of people fall victim of when they see PVS, because it's really, really cool technology, is you think to yourself, hey, if I got this way of making an image and putting a bunch of stuff in it and then throwing it to 100 target devices, then really I don't have to have a process that I engineer my build. I can just boot up this thing in private image mode. I can make all my changes, and then I can reapply that modified disk image to all my target devices. And I don't really have to worry about a change control process or any kind of crazy documentation or build procedures. I can just do all my changes in my disk image and assign them to all my targets. The problem is that will work fine your first couple image revisions. And then somewhere along the way, someone's going to make a registry change or install an app or something that's going to break that core image. And you're going to have no idea how you got there to be able to piece it back together from a base image. So very important thing, I think, when you decide to use PVS, make sure you have an established process of how you build your images and always follow that process. And we'll talk about some presentations that were done last year that will help you understand that better. So mythical best practices. So
yeah, my favorite topic. So PVS should be physical, not virtual. It's not true. For some cases, I'm actually a fan of physical PVS servers because I'm a fan of doing big scale hardware boxes that can support many users. But at the same time, in most of my deployments, I have 2 PVS servers, physical, for hosting actual user VMs, and I have some couple of virtual PVS servers that I'm using for maintenance. That's one use case. Another one use case is when you can't afford to have physical server. As example, I had a customer that had many data centers where they run in XenApp servers, and they basically had 2 physical boxes there and running 4 XenApp VMs on each box plus 1 PVS server. to stream this. So 8 virtual machines with XenApp, 2 virtual machines with PVS, and everything is on 2 physical boxes. If they will, if for some reason they was decided to go with physical PVS, they need additional servers in this case, and it can be really expensive and harder to manage. So there is a lot of use cases, and if you will configure your servers properly, if you will not overcommit them, if you're using virtualization, you will not overcommit them, you will configure networking properly, you will have almost the same good results as you will have with physical servers.
So it pretty much becomes a challenge around management. If you have to deploy PVS infrastructure in multiple sites, because the thing to keep in mind about PVS, and I think people that are maybe not familiar with PVS don't understand this, but the way that it does the streaming, you have to have the PVS server and the target devices on the exact same LAN. This is not technology that can be used across WANs, so you need to have this all in the same location. So if you're a global XenApp farm and you have XenApp servers in like 10 different sites around the world, there is no way to avoid not having dual redundant PVS servers in every single site that's serving up your images. So now this becomes a situation, if I have 10 sites, 2 PVS servers that are physical, I need 20 boxes globally to support my XenApp streaming, even if I only have 1 XenApp server in that site. So you really have to start making a determination of, do you want to use PVS everywhere? And if you do, you need to make sure you understand that you have to have 2 PVS servers at each site. And if you're doing that physical, that could add up to a lot of cost.
Yep.
So it's important. Segmented VLANs for PVS streaming. So the age-old best practice on PVS was to make sure you set up segmented VLANs so that all your streaming traffic goes across a separate network. This used to be the case. A lot of people would follow this method, but it's not necessarily something you have to do. If you have gigabit Ethernet or 10 gig Ethernet in your data center, you can happily coexist your PVS streaming traffic along with your other traffic on the same VLAN. The most important thing where segmented VLANs becomes a level of importance is if you're using the PXE-based method of booting your target devices, you're going to end up having some problems if you have an existing WDS, SCCM, Altiris, whatever environment that is relying on PXE booting.
Or if you use some IP phones that configure it on the startup, you will find this situation. And in my practice, I usually don't worry about network performance when I'm separating PVS traffic to the separate VLAN. I usually care about PXE and all this boot stuff that is important on the very beginning, because it's much easier to implement one separate VLAN than changing all infrastructure for the customer. So that's the reason, yep, in most cases.
Sense.
PVS is, there is a lot of talks about PVS with MCS, what is better, what is scalable, what is not. A lot of people believe that MCS is just for small customers and it's not scalable. It's scalable enough, and if you just compare the architecture, how services are running on MCS and which of these services use it when you deploy in Zen desktop with PVS, almost all of the services are used. So it's not about scalability of DDC. It's more about scalability of your storage. But if you will plan everything, if you will compare what you have right now, and you will place your right cache in the proper on the proper ones, on the proper storage arrays, you will have good performance. So everything is scalable if you know how it works and if you know how to place all this stuff to the right location.
I think the reason why Citrix originally went down this path of telling people that MCS was for proof of concepts or for small environments was really 2 reasons. Number one, PVS was well-established technology. It had been out for many, many years at this point, and they had lots of success in large customers deploying PVS. So it was a no-brainer to say PVS is the enterprise large architecture default standard of how to deploy XenApp and Zen Desktop. MCS, of course, is a very, very new technology. It's only been out for a couple of years at this point, 2 years roughly. So they don't have enough reference customers using MCS at large scale to be able to get behind the architecture and say, yes, we believe that this is a good architecture. I think the second problem is if you look at the storage subsystems that have happened and what's gone on with the storage industry in the last 5 years, to think that you could put 40,000 desktops on a classic SAN that people were using over the last 5 years is absolutely nuts. There's no way you could sustain that without melting the disks on a traditional SAN. But what's happened with SAN vendors over the last few years is a lot of them have started to learn how to combine things like SSD, PCIe Express, Fusion IO cards, as well as automated tiered storage and data duplication inline and all these kind of things, that it now is reaching a point that MCS can be a very practical way of scaling hundreds and thousands of desktops as long as your storage system can support it. And I think that's the biggest, magic 8 ball in this whole thing is the customer storage going to be able to support thousands of virtual desktops on MCS? That's a question that nobody can necessarily answer without actually measuring it and testing it. So I think Citrix's default answer of PVS is the way to go is just because they know that PVS does defer some of the I/O problem in an enterprise environment, so they're more comfortable recommending that for large implementations. But there's no reason why you can't use PVS for small and why you can't use MCS for large, as long as you understand the storage impact and you know how to solve that.
And PVS is a part of the same product, and for many sales guys, it's much, much easier to say that PVS is more scalable. And I think a lot of these talks, just because sales guys say that it's scalable without knowing what is it exactly.
And there's a number of vendors out here that you can talk to about scaling virtual desktops on storage. I know Atlantis is here and several other people. If you use a solution like Atlantis, you can use Atlantis combined with MCS or even Atlantis's own clone technology, and you can avoid the necessity of PVS if you want to go that route. So other things, PVS doesn't require SCCM. This is kind of what we talked about before in terms of how you create and manage your images. It's not to say that you necessarily have to have SCCM to do PVS. You could very easily build a baseline operating system image, install your applications, and put it into PVS and go away happily. The problem is that over a period of time, over several years that you're working with this, the number of images that you have to maintain and how you get updates out to those images and how you rebuild an image from scratch, if you have to rebuild it from scratch to troubleshoot a problem, is going to become very, very difficult if you're not doing some kind of image management solution that lets you basically boot a machine, push a button, and rebuild it from scratch. So along those lines, Aaron Parker gave a session at Citrix Synergy and I think at BriForum in London on using MDT, which is, of course, is a free product from Microsoft, using MDT with a task sequence to build beginning to end OS, core applications, XenApp, and PVS target device software and convert it to a PVS template all in one task sequence.
Yeah, the funny thing with PVS that most of the customers are doing manual work, installing Windows, installing applications, installing all this stuff. But everybody knows that automation is the key. And yes, it's okay, you can run, you don't need to install applications on all your VMs manually, you need to install it on just one VM. But if you will manage multiple different images for different use cases, you need some management functionality. It can be SCCM, it can be MDT, it can be, even if you have some scripts that you use it previously to manage your applications, and if they work correctly, use them to update your images on PVS. Do some automation with PVS image management.
Yep, very, very key.
I should stay here and see what's happening next. So you need to know how your antivirus works, and you need to place it on your VMs, on your master images. Some people think, and some people even talk about this publicly, that PVS can replace your antivirus because you don't have user files there, and if something will happen and you will catch a virus, you just need to restart the computer and that's all, everything is fixed. Yes, everything is fixed. But since your VM is still running, some of these VMs are still running, and there are some users, if you will get a virus on your desktops, it will affect other infrastructure, because not all of your infrastructure is on PVS. So you need to have antivirus. You need to have antivirus solution. It may be something on the separate servers that is scanning your VM memory or doing something. It's not replacing antivirus. It's not PVS is not a security tool. It's not, completely not.
PVS is easy to implement. Now, of course, this is debatable depending on whether or not you're building it to be highly available and building it to scale a large number of images and that kind of stuff. But when you think about implementing PVS in a customer environment, you have to figure out how you're going to do your DHCP, and particularly DHCP high availability. You have to figure out whether you're going to use PXE-based boot process or if you're going to use boot ISO or boot, local boot image. You have to make sure you figure out high availability for the PVS streaming service. All of these things are what I would consider probably not the typical things that most XenApp or XenDesktop admins really think about that much. One of the most critical mistakes I see at customer environments is they'll implement PVS, they'll have it running, they'll be running 10 or 20 or 30 XenApp servers off of it, and they've got one PVS streaming server. Or they don't have high availability for PXE and they're using PXE boot. Or they don't have high availability for DHCP and they're relying on DHCP every single time one of those machines boots. If you are implementing PVS, you need to treat it like everything else that you focus on for high availability. Make sure that all your infrastructure has at least dual redundancy, that it has some high availability model. Also, the PVS database, you have to make sure that's highly available as well. It's very, very important.
Single image management. PVS is not giving you possibility to use one image because there is no application management in PVS. If you are using PVS for XenDesktop or for XenApp, most of the users, most of the customers need some applications there. They don't need just an empty Windows box. And most of the customers are using VDI for different user groups, and they need different set of applications. So in any case, you will have at least 2 or 3 or 5, or how many applications you have, how many user groups you have. You will have a lot of images for different user groups. So it's not a single image management solution.
So this one we kind of already alluded to when we talked about high availability, but when you do PVS, you have sort of 2 different options you can use to boot your target devices. You can boot off of PXE, or you can boot off of a boot ISO or local boot disk that has a BDM code on it. It's going to depend on you on which one you want to choose to do. I did lots of implementations before based on PXE, and I can tell you that a lot of customer environments, this is very questionable on stability depending on how many other things they have going on in their environment, whether somebody makes network changes, that the helpering is gone away, and these kind of things. So from my perspective, over the last few years, most of the PVS implementations I'm doing today are all on a boot device manager, local storage on each machine, or ISO-based. The thing you got to be careful with ISO-based is some hypervisors will eject the CD when you boot the machine, and then of course you can't get to your PVS streaming server, and then your servers are not booting. So I prefer to use the local disk option and provision the machines that way.
I had a customer that had about 50 XenApp servers, and this service was streamed from PVS. They was in different locations. We had a lot of PVS servers around the country, and the problem was that they had ISO for booting these VMs, and this ISO was stored on the small mega storage. Not the storage that's certified for something. It was just temporary storage during the pilot to test how it works, and it's a
consumer.
Consumer-based device was stored somewhere in the closet without any additional power supplies. When someone just picked it to move to another location, all the XenApp servers was without ISO server and was not able to boot.
And I think this is particularly dangerous for the XenApp use case, because think about XenApp. Most of us are in a pattern where we're booting our XenApp servers daily or weekly or something like that. When you have a PVS target where all 50 machines are booting around the same time over a weekend or something like that, and then the boot ISO is missing, all of them are dead. Like not a single one of them is functional. So this can be a very dangerous situation to be in.
Did you ever implement both, like PXE first, then boot ISO second, or vice versa?
No, typically if I have isolated networks where I can do PXE and I can do high availability for PXE, we can do that. But honestly, most of the times lately I've been using all boot image because it's just way easier. It's more predictable, I guess is the way to describe it. Nothing can really interfere with the availability of that coming up each time unless the storage that you're using is down. But that's usually made highly available for your hypervisor.
Some people think that using boot device manager can make your management harder because you will have multiple boot device manager images across all VMs, and what will happen if you will change IP address of your PVS server? How often you change an IP address of your PVS server? Not often.
Yeah. It can create some additional management, because if you do add or remove a streaming server, you want to modify the bootstrap image, you will have to go back and regenerate those, but it's honestly not something, if you build it right from the beginning, you really shouldn't have the necessity to modify that image very often. So.
High availability. High availability for PVS is not only having two highly available PVS servers itself. You need to have a database. Database is critical for PVS implementation, and PVS should be available all the time for all PVS servers. You can use offline database, but I personally prefer to configure database mirroring. It's easy technology that you don't need to have some specific SQL skills. You don't need to know how to manage Windows clusters. Even it's easy, but database mirroring on SQL Server, on Microsoft SQL Server, is extremely easy to implement, and it's predictable. It's easy to restore your database in case of failure. It's easy to manage, and I encourage you to use database mirroring for all your implementations. Another one scenario that I like to do, not all the time it happens, I prefer for large Citrix deployments, I prefer to have dedicated SQL servers that are hosting all databases for all Citrix products, like for XenApp, for XenDesktop, for PVS, for Edge side, everything hosted on dedicated servers for all XenApp products. I can put vCenter database on the same box, on the same database mirroring, not cluster installation. A lot of products support database mirroring, and as soon as you start using it for PVS or for other products, you will find that you can configure vCenter. Everything can be almost everything can be configured to use database mirroring, and you will find that it's really good and easy to implement solution. And
if you're going to use database mirroring, it's always a good idea for faster failover to configure a witness server. So you have a third SQL server. You can have a shared witness, so you can have one witness server that's doing database mirroring for your primary and your secondary, as well as that can be a witness server for other SQL mirrors that you have out there. So you don't need to have a dedicated witness per mirror. But it's a really nice way to make sure that your failover is as instantaneous as possible.
Yeah, and what is great with database mirroring, you don't need to manage it. If you have a failover, you don't need to go somewhere and switch something to turn it back. Everything is automatic. Database mirroring, I use it since SQL Server 2005 with XenApp, with Presentation Server 4. I started using it with Presentation Server 4. And I had situations where I never checked database for Presentation Server for a couple of months. I never checked that what was happening there, and during this months I had scheduled maintenance on the SQL servers. So everything was automatic. If someone needs to manage my servers, I mean to install updates, they can do this, and they can restart my server. Nothing happens with PVS servers or other servers that using mirrored database.
And I think the key thing about mirroring, and I always encourage customers to use mirroring over SQL clustering, that kind of stuff, is because it is so easy to set up and manage. I mean, if you look at SQL clustering, it's not to say it's a worse solution, it's just a lot more complex to set up and manage a SQL cluster. Database mirroring is incredibly simple to set up and monitor.
But for some people who have enough paranoia in their mind, they can set up 2 SQL clusters and run database mirroring between these 2 clusters. It will work, and it's more highly available. If you need this, it will work.
The one thing I always remind people to, and this probably sounds quite obvious, but sometimes people miss this. Just because you're using mirroring or SQL clustering doesn't mean you don't have to back up your databases. Because if you have some level of corruption of data inside the mirror cluster, that of course replicates to the other location, and you have that corruption everywhere. So it's very important to make sure that you are still doing your database backups on a regular basis so that you can restore them if anything goes wrong.
What is great with database mirroring, because of the database model that you use it in the database mirroring, it grows transaction log grows very fast, and if you forgot to set up backup for your database, you will be notified by someone who check the disk space on your SQL servers. You will be notified in a couple of weeks after your deployment.
Then the last one on mythical best practices is that PVS optimizes the OS out of the box. Now this is going to sound a little bit contradictory because the PVS software when you deploy it on a target device does provide some base level optimizations out of the box. There are some tunings that are done. But again, these are some very, very baseline tuned settings that are in the software. It's not enough to optimize Windows 7 or Server 2008 R2. So you do need to go above and beyond that. And there are lots of guides published out there on what tunings to do for Server 2008 R2 and Windows 7. Quest has a VDI optimizer available for free that you can run that makes a bunch of the tunings. And again, always make sure you test this in your environment, do your baseline scalability testing. In addition, Pierre Marmignon on formerly Citrix Tools and now on Norscale, he has some optimization settings for virtual desktops and XenApp servers. But again, please make sure you test in your own environment with these settings. Some of them may cause problems with your applications. So we want to talk a little bit about image types. And within PVS, there's really three primary image types that you can configure. There's a private image, which is a one-to-one model. There's a standard image, which is a one-to-many model, so one disk image for many target devices. And then there's a differential image model where you have one-to-many plus a differential, so sort of kind of like a link clone concept. So we'll talk a little bit about what each of these does for you and how they're leveraged within a PVS environment. So the first one is private image. And in the case of private image, you're going to have multiple disk images per target device. And these things can be stored back on the PVS server or back on the backend SAN, wherever you want to decide to store them. And the key thing about the private image model is that each target device has its own separate disk image. And what's good and bad about this is that each device can have its own unique customizations that are stored in its separate disk image model. What's bad about this is absolutely no different from having a bunch of virtual machines with their own unique disk image sitting back on a backend SAN. It provides no real storage I/O savings in terms of capacity because whatever the vDisk size is, it's still going to sit on your backend SAN. And it doesn't really provide you the level of I/O reduction in the PVS RAM caching because you actually have multiple different disk images. So the utilization of the PVS RAM cache is less effective because they're unique disk images.
But it can be a really good solution if you want to implement something like boot from SAN or boot from iSCSI, but you don't have enough money to buy this hardware that will support boot from SAN or boot from iSCSI. It can be really useful for booting your physical XenApp servers if you run them, if you need them, for boot them from the central location to have all images stored in the central location and manage this farm in the old way how you use it before provisioning services.
Now, private images are, of course, necessary when you're making modifications to your disk images that you want to roll out to your multiple target devices. So you will have to switch a machine into private image mode to make your changes because this is the only mode that's going to allow you, well, not the only mode, but this is the primary mode that will let you do read-write changes. So if I have to install a new app into my XenApp silo up here, this blue silo, I put it in private image mode, I make my changes to my disk image, and then once that disk image is done, I'll then turn that into the shared image mode.
What about the maintenance mode in PVS for your versioning?
So in my opinion, private image mode is a mode where, that should be used to create new version, new type of your vDisk. Like you creating a vDisk for developers, you creating vDisk for accountants, and the best practice that I'm trying to use is to install applications on the copy of vDisk. So just to create new empty image, install XenApp or XenDesktop VDI agent, seal this image, place it somewhere, backup it somewhere, and then copy it as another file. Open it in the private mode and install applications that are required for some specific user group. Maintenance mode is maintenance mode. It's support versioning mechanism, and you can roll back. You can create new version. You can use test versions. Test version of your vDisk on the test VMs. So it's kind of different from the private mode.
Yeah.
Different use cases.
It's more so used just for minor changes that you want to make as opposed to composing an entire new image. But the differential updates that are in the versioning model are effective if you want to make small changes. It's just eventually you're going to want to compose those down to a regular image, because each of those differentials is going to add a little bit of performance penalty to layer them on top. So you want to make sure at some point in time you compose those back down. Standard image mode is what you're going to use for most of your XenApp servers. Yep. And in standard image mode, it's basically taking that private vDisk that you convert into a standard or shared image mode. And in that circumstance, every target device that boots that standard image is going to have a read-only access to that vDisk image file. Now, of course, Windows can't operate completely in read-only mode, so then you're going to have a write cache that's going to be stored in multiple different places. We'll talk about write cache placement in a minute, but the write cache is basically that disposable write filter that we talked about. So anything that happens on the box after people are logging on, the user profile, any kind of temporary files that get written, all of that stuff is going to get caught up into the write cache. And then that write cache is going to get discarded each time one of these machines boots. So in the prior model where we talked about the private image mode, the virtual disk changes are persisted between reboots. But in this model, the virtual disk changes are discarded at each reboot. So what's great about this model is in a XenApp scenario where we might have 50 target devices all using the same disk image, we always go back to a clean image state every single time the machine reboots. We don't have to worry about changes that are made by the users or any kind of pollution on the system, because as soon as it's rebooted, it all goes back to a pristine state. So it's a very, very effective way to do XenApp. Now, I'm not as convinced that using this for VDI is necessarily a great model. And part of the reason for that is because I'm a big fan of persistent VDI. I still feel like we're far enough away from the technology that enables us to have non-persistent pooled VDI for large diversities of user groups. So trying to use this model for VDI becomes very complex unless you have a situation where you've got a call center, you got 1,000 people all running the same 5 applications. Then yes, of course, you could build this on VDI and do it with the shared image model like this. The challenge I always put forth to people is, if you have 5 applications used by 1,000 users, why wouldn't you serve that on XenApp? Like, from my perspective, it's crazy to put that on VDI just for 5 applications. The only thing that would drive me to VDI for a simple use case like that is if I had a set of applications that I could not support on server OS and was driven to have to use VDI in that case. But that'd be the only use case where I'd use this model for VDI. And then the last model, you want to cover differential?
Yeah, differential images, it's basically temporary, it's an image with temporary persistence. When your write cache is persistent between reboots, and there are some use cases for this, like if you want to install some application that require the restart, or users are doing some work that require this restart. Like if you're using your VMs for developers, this can be a good solution. They need to have their data persist on the desktop during the restarts between restarts. Another one use case that I seen is for one university. It's not a VDI use case, but it's a use case for PVS. For one university, we did implementation of high-performance Windows cluster to compute some stuff, and PVS was used to stream this operating system, Windows Server operating system, to all hardware servers. But there was a problem with high-performance cluster require that all seeds, security identifiers of all boxes on the PVS needs to be different. And because of this, standard mode of PVS server, when PVS is changing the name and the password of computer, was not working correctly with high-performance Windows cluster. So what we use it scripted installation. So all target devices are starting from PVS. They don't need hard drive. They use sysprepped image for PVS, and then they join in domain using the scripted install. They restart after the joining domain, and they work well. So we don't need to store data. So differential mode is not something to have a persistent storage for user data or for user applications. It's a temporary storage that just persists between restarts.
Yeah, the key thing about the differential image model is that while it does preserve this differential delta for each image, and you are getting the storage savings and the I/O savings of the common vDisk, this differential volume is discarded whenever you make a base image update. So this model is not really useful for most organizations because they do have to update their image from time to time for Windows updates, for new application installs, that kind of stuff. And when you do that, you will throw away the differential data disk. What's more common when people want to have some level of persistence is to attach a second disk volume to the VM that is their persistent volume, and that's where they'll store the event logs and McAfee updates and all these kinds of things. But the key difference between what Denis is talking about with differential image mode and the static persistent volume that you attach to the VM is the static persistent volume is going to come up as, let's say, a D drive. I have to do work to re-engineer the applications to make use of that D drive. Whereas in a model with a differential image, this is basically a layered disk subsystem on top of the existing C drive, so I don't have to re-engineer my applications to make use of the differential volume. So it's a little bit different in terms of how you have to set it up and work with it. So use cases for both, but for most people, the differential image model is not as useful. Let's talk about gold image creation really quick. There's this notion within virtual desktops or within XenApp servers that you can have one image for all of your servers. And I kind of think of this as like the used car salesman model, where like the salesperson comes in and says, imagine if you had just one image for all of your users. And in practice, it sounds like it would be phenomenal, right? Like if I just had one disk image and all I ever had to do was patch that one image and reboot and all my people had all the same contents, that sounds fantastic. Like why wouldn't you not want this? The problem is this is more of kind of one of those fairy tale things that, you know, maybe for some customers in some simplistic use cases they can get away with this. But a lot of the customers I work with have, you know, thousands or tens of thousands of desktops, hundreds or thousands of unique applications. And when you start picking apart the permutations and combinations of who needs which apps into each virtual desktop, this just becomes impossible. And there's a lot of new technologies that have been coming out in the last 2 or 3 years that are starting to make this potentially be more practical. So 2 vendors that are in this space that have done some stuff lately, or actually 3 vendors. Unidesk has a solution that allows you to solve some of these challenges. Cloud Volumes has a solution that lets you solve some of these problems. And also FS Logics, who is out here right now, has a solution that can solve some of these problems. They each do it a little bit different way. Grab me after the session if you want to learn more about those. We can talk about it after the fact. But the idea of having one common image that all your users are going to share is sort of more of a sales pitch than it is a real practicality for most people. So let's talk a little bit about gold image creation.
Yeah, you need to know your applications. You need to know what applications will run on your golden images, and you need to automate this installation. You need to use SCCM. You need to use any tools that that manage applications on your physical desktops. You still need to find the way how to use it on the PVS. If it's MDT, it's easy. There is a good article. Oh, yeah. Good. There was a good presentation from Aaron. But you need to know what is installed on your VMs. So never do P2V migration. I mean, do not take your physical images and do not create exact copy for your VMs that will be used on the virtual desktop infrastructure. Take a time and look what applications are installed, what applications are needed, what applications should be removed from the golden image.
And the key thing here as well is it makes a lot of importance of how you do your persistence of data. Because in a traditional shared image model for PVS, when you reboot that machine, all the contents of the C drive revert back to the pristine image. And this can obviously be bad for anything that we need to hang on to history of data. So the target device software automatically will handle things like event logs and that kind of stuff, but any third-party software you have installed, like antivirus that has signature updates that come down, if you have SCCM agents that have their inventory data that's stored on the machine, edge site, all these kinds of things, you need to make sure that all of those components are storing their data somewhere off of that VM, because the minute that you reboot the VM, all of that historical data is lost. So if you have an InfoSec team that does some kind of forensics in the event if something happens, you need to make sure all of the data that needs to be analyzed for forensic data is actually being persisted somewhere off of that C drive image that's going to be reset each time. It's very, very important. And image creation, as Denis kind of already talked about, Aaron Parker did a fantastic session on this last year at Synergy, talking about using the freely available MDT solution from Microsoft to automate an entire end-to-end build process of a PVS target device for XenApp. So it includes deploying the OS, applying Windows updates, installing XenApp, installing the PVS target device software, and going through the entire process of making that image and then putting that into PVS. So it's a very, very cool session. In addition, Pierre Marmignon has a XenApp cloning tool available on his site that can be used with PVS. Of course, not officially supported by Citrix because it's a third-party tool. And Pierre also is working on a new tool called Project Andromeda, which he actually has had now for I think about 2 years, but hasn't released it. That is a complete end-to-end automation solution for XenApp and XenDesktop and PVS environments, automating the entire build of all of the infrastructure. So it's a very cool tool. Hopefully that will be coming out soon.
Yep. PVS write caches, there is different write caches can be used with PVS, and some of them have some pros and cons. The most used write cache type is cache on the device hard drive. When people are new to PVS, they think that what does it mean, hard drive of the device? Should it be a physical hard drive or something? It's a virtual disk that attaches to your VM. And the main question is where you store this virtual disk image. You can store it on the SAN, and it can be a big problem for your deployment because all writes will go to your SAN, which is not ready for all these writes from different VMs. It can be placed on the local hard drives of your hypervisor. But in this case, you will lose ability to use vMotion or ZenMotion or live migration or DRS. But do you really need live motion or vMotion for your VDI infrastructure? Do you want to move these VMs between different hosts if we're talking about XenDesktop? Or do you want to move your XenApp VMs between hosts? If you size it your environment properly, you already have multiple hosts that are hosting multiple XenApp servers that can host multiple users. If you need to do maintenance on your host, just drain sessions from your XenApp server and shut down the host. If you're using XenDesktop, put your hypervisor into maintenance mode and prevent new VMs that will start on this host. And after a couple of hours, you will see that users started all the new VMs on the host that you usually using during the maintenance. You can avoid all types of live migration in VDI implementations. And it will allow you to use local resources on the server. It's not only a cache type when you're using local hard drive. You can use 3D graphic cards using pass-through. You can use you can pass through network adapters if you need. It's not a big problem for VDI. You can live perfectly without ZenMotion or vMotion.
So I want to add a bit to that because I think it's, that becomes a bit of a political discussion point for a company. And what I mean by that is I work with some customers that don't have good controls in place on how the users interact with their virtual desktop. So if you're an organization that does not enforce people either through policy or through the technology to force log them off at the end of each day, if you let them sit on their VM and just disconnect and potentially sit out there for 3 or 4 weeks, then vMotion and DRS becomes a much more important problem because you can't oftentimes wait 3 or 4 weeks to do host maintenance. But if you have strict policy controls in place or technology controls to enforce the policy that says at the end of each day you will be forced logged off, so save your data and get off the system, then I agree with Denis that the vMotion and DRS becomes less impactful because at any point in time you put a host in maintenance mode, you can wait 8 to 12 hours for the system to drain, do your maintenance, and then add it back to the pool. And as each user comes on, they'll get provisioned on a new hypervisor host, and you don't have this problem. But it all depends on the management politics within your organization, what you're willing to accept for usability. Cache and device RAM. So there is an option, of course, to cache the write cache data into memory on each target system. And this, of course, because you're caching the data into RAM versus caching it onto disk, whether it be local or SAN, is going to provide the highest level of performance. The big problem that I see with cache on device RAM today is that there is no built-in facilities within PVS to overflow RAM cache and go to disk as a backup model. So the unfortunate reality today is if you do cache to target device RAM and you run out of cache space, the machine can blue screen. So this is obviously not a great solution. I would say if your organization has a very good control over how much write cache you're using, and you know exactly what your write cache number is, like let's say it's 2 gig, 5 gig, 8 gig, and you know it never exceeds that, then you can do a 10 or 12 gig target device RAM cache, and you'll probably be fine. But you need to make sure you monitor that from time to time and make sure you don't ever run into a situation that you do exceed that write cache, or you're going to have systems that freeze or crash. So very important.
Be careful, because any user can can just open Internet Explorer and try to download some ISO file,
yep.
or open CMD prompt and create a loop script that will copy something a couple of times, and you will lose your write cache.
Yeah, so it's very important that this is still somewhat subject to failure. You can cache on server on the PVS server. My personal preference is not to put anything on the PVS server other than the read caching that it's supplying, because if you cache on the PVS server, you're using the resources of that box to perform all your write I/O, and that's going to degrade from the capabilities of it performing read caching and serving up additional target devices. So my preference is not to cache on server.
Cache on server persistent. You can use it as a temporary storage for your differential images in the scenarios that I described. So it has use case. It's not a common use case. Most of the customers can avoid this persistent write cache, but for some scenarios it's required. The most important question with PVS write cache is sizing. What I personally trying to do in most of the projects, if I have a time to do this, after the proof of concept, when we proved to the customer that PVS is a great solution for them, we move pilot to and during the pilot, we're using write cache on the server to understand how it's actually growing, because it's much easier to control the size of the write cache when it's centrally stored on the server. Customer understand that it can be a huge impact on performance, but during the pilot, it's a great solution to size your write cache properly, or find why your write cache is growing. It will be much easier during the pilot. But after the pilot, you need to move to the device hard drive in most cases.
The key thing when you're figuring out that write cache size, of course, if you're in a pilot mode or proof of concept type mode, is to make sure that you understand that the volume of users that you're testing in your pilot or proof of concept is mimicking what you plan on testing during production. Because, of course, the write cache will be made up of whatever the user profile contents are. If you're using something like roaming profiles, hopefully you're not, but if you are, and the roaming profiles for certain users are hundreds of megabytes, and you have 50 users log on to a box and they're eating up all the write cache with their profiles, if you only did your proof of concept tested 10 user or 20 user sessions, your write cache estimations are going to be way off. So you need to make sure you understand the write cache sizing for the number of users you're anticipating to go live in production with. PVS server tuning. This is one I like to do in most of my projects when I'm dealing with PVS, and honestly, I like to do RAM reservations for any type of XenApp server workload. Again, as I said, I don't like to do memory overcommit in virtualization projects. I like to allocate the amount of RAM for the XenApp host and for the PVS servers that I'm actually expecting I'm going to be using through, of course, testing and benchmarking and sizing. And if you're going to do this, do a RAM reservation on your hypervisor host, and what that does for you, if you're on, let's say, a VMware platform, it avoids doing the vSwap. And the reason why avoiding vSwap is important is because when you vSwap, you're going to storage. The minute you go to storage, things get slow. So if you can avoid vSwapping by doing a RAM reservation, you save a lot of storage size and impact on performance.
CIFS optimization. There is a blog post from Dan Allen on the Citrix.com that describes why you need to optimize your CIFS storage. But please read this post from start to end before implementing these registry keys. There is a lot of registry keys that can apply only to Server 2003, and you need to understand what you're actually doing before implementing these registry keys.
If you're implementing your solution on a VM platform, it's a very good idea to optimize the TCP network offload configuration, so TCP chimney, receive-side scaling, TCP AWSD. There are lots of links out there that you can find the specific items that I'm talking about here. If you just Google for those values, you will find tuning techniques for optimizing those for a VM environment. If you want to run PVS on a hypervisor solution, but you also plan on scaling a large number of target devices in the hundreds of target devices, you may want to consider doing VTD pass-through. Keep in mind, as Denis already alluded to before, if you're doing graphics GPU pass-through or NIC pass-through, you cannot do any form of vMotion or live migrating a VM from one host to the other because you are passing through that physical hardware. But that's a good way of getting higher scalability on PVS targets. And the last one?
The last one, if you scale in your PVS servers to host, especially in VDI scenarios, if you will host many VMs, you need to adjust the number of ports that are listening for the connection and how many threads will be used for connect your virtual devices. Otherwise, your new VMs will not start and will be not able to connect to PVS server. There is a good blog post on the Citrix.com, and all values that needs to be changed, they are really good. They have good documentation on the Citrix eDocs website. All values are described, so please take time to read it before changing.
The default configuration of PVS will support up to 160 target devices. If you want to stream more than 160 target devices, you need to tune the number of threads and ports to allow more target devices to be supported by a PVS stream server. So PVS target tuning, this is for the individual XenApp or XenDesktop machines that you're supporting through PVS. We, of course, see Chapter 1. We talked about a lot of optimizations in Chapter 1. If you're doing antivirus, if you see the results from Project VRC, it's a very good idea depending on which AV you're using. McAfee as an example. McAfee will take SHA-1 hashes of each file that it has scanned previously and stores it into the McAfee database on the client. So it's a good idea to pre-scan your images before you seal them and shut them down to make sure that it won't scan those. Of course, if you're not scanning on reads, then this is sort of a moot point anyway. But file system optimization. The key one here, and this is one I put in there, whenever I do a XenApp or a XenDesktop project, I always make sure that when I boot something up and I'm going to hand it over to a user to have them use it, I will monitor that VM at random times throughout a week or 2 week period. Remote assistant to the user, run process monitor, have them do their thing, save the process monitor, log out, and then go take a look at it offline. I'm looking for things like excessive verbose logging of some applications. Sometimes applications will write data out that's like a megabyte per minute or 10 meg per minute of log data that the developer accidentally left on. These things can really cripple your virtual desktop. We talked about this already, network tuning, operating system tuning. We covered a lot of that in Chapter 1. This is one that Pierre likes to do a lot. I've not done a lot of this with my customers, but he always likes to do an automated pre-login to a XenApp PVS image to make sure that the write cache gets preloaded. It will solve a little bit of performance impact when your second and tertiary users log on. And if you're doing RAM cache, reboot daily to flush the RAM cache. So high availability?
Yeah, always take care about high availability, and don't forget to change properties of the vDisk to enable high availability, because I've seen a lot when I'm finished with the project for the customer, configured highly available PVS servers, and then customer introduced a new vDisk, and they forgot to change properties of vDisk and enable high availability. And they obviously have a problem.
So we're out of time here. I just want to cover really quickly. Make sure you do PXE high availability or use BDM on all your hosts to make sure you can boot your PVS images in case that you don't have high availability for PXE or DHCP. Beyond that, thank you very much for your attendance.
Thank you.
Appreciate it.